Let's continue our example on limits. So for our next example, we have the limit of square root of 1 plus y minus square root of 1 minus y over y as y approaches 0. So here, if you have radicals in your numerator, you need to rationalize it in order to solve this problem. So let me write the problem again here. The limit of square root of 1 plus y minus square root of 1 minus y over y as y approaches 0. If you're faced with this problem, to rationalize it, multiply the numerator with the conjugate, square root of 1 plus y plus square root of 1 minus y, and so that the impact is that so that the expression will not change, so this expression will not change, we need to divide the numerator with the same term, 1 plus y plus square root of 1 minus y. So basically, since the numerator is the same as denominator, then the quotient will be 1. So in that case, it does not impact the original expression. Now, when we multiply this term by its conjugate, this is still similar to, if you recall, the difference of squares, a squared minus b squared is equal to a plus b multiplied by a minus b. So let me just illustrate this further. You can see here, we can treat square root of 1 plus y as a, and square root of, this is square root of 1 plus y is actually a, and square root of 1 minus y is actually b. Same as here, square root of 1 plus y is a, square root of 1 minus y here is equal to b. We can see here that the numerator here is equivalent to a plus b, which is this one. And in our original expression, square root of 1 plus y minus square root of 1 minus y, we can treat this as a and treat this as b. So in effect, this is basically a minus b. So you have here a plus b, and you have a minus b. And in the equation for difference of squares, the binomial a plus b multiplied by the binomial a minus b will lead to the difference of squares a squared minus b squared. So what do you do here? So you have a minus b, a plus b. The difference of squares is now a squared minus b squared. So we take a square now, we take the square of this term and the square of this term. So we can express this now as the limit of, if we now take the square of a square root, this will simply be 1 plus y. So the square cancels the square root, and you're left with this, 1 plus y, minus the square of square root of 1 minus y. So the square root is cancelled by the square. This now becomes 1 minus y over y multiplied by square root of 1 plus y plus square root of 1 minus y. The limit as y approaches 0. Now, let's just clean this up a bit. Let's erase this. Okay, now if we simplify the numerator here, you will have the limit of, so this will be, if you make this positive, this will be negative, and this will be positive. So it's 1 plus negative 1 will be 0. So these two will cancel out each other. So you have y plus y will give you 2y over y multiplied by the square root of 1 plus y plus square root of 1 minus y as y approaches 0. Y here cancels the other y, so now you have the limit of 2 all over square root of 1 plus y plus square root of 1 minus y as y approaches 0. Now, substituting now y is equal to 0, you will get 2 divided by square root of 1 plus 0 plus square root of 1 minus 0. This is now equal to 2 divided by square root of 1 plus square root of 1. And now square root of 1 is 1. So you have here 2 over 1 plus 1 is equal to 2 over 2, which is now equal to 1. So our final answer is 1. Now let's see another example here. We can see here limit of u over 3 minus square root of u plus 9 as u approaches 0. So again, you have a radical at your denominator, and to solve this, we multiply this by the conjugate. This is similar to our previous example wherein you have a radical in the denominator this time. The previous one, the radical was in the numerator. Now this time around, the radical is in the denominator. So let's multiply it by its conjugate. So let me write this now. Let me just put a color. So the limit of u, then 3 minus square root of u plus 9 as u approaches 0. Let's multiply it by the conjugate 3 plus square root of u plus 9. Now, to make this term equal to 1, so as not to impact your original expression, let's make the denominator also equal to 3 plus square root of u plus 9. Now, similar to what we did before, the limit of u multiplied by 3 plus square root of u plus 9. Let me just write that first. Now, similar to what we did before, since you're multiplying the denominator with the conjugate, with its conjugate, now we can rationalize the denominator. So you take the square of this and the square of the other term. So 3 squared will be 9 minus the square of a square root. You just cancel the square root, and now you have u plus 9. Now let me just simplify this. Let me have some space. As we can see here, we simplify this further. You'll have here, if you make this positive, this will be negative, and this will be negative. So now, this will be the limit of u multiplied by 3 plus square root of u plus 9 all over 9 cancels the other 9. So you're left with negative u here as u approaches 0. So u here cancels the other 2. Now you're left now with the limit as u approaches 0. So 3 plus square root of u plus 9 over negative 1. Now substituting u is equal to 0, you will get 3 plus square root of 0 plus 9 over negative 1. If you simplify this, you have 3 plus 0 plus 9. 0 plus 9 will be 9. Square root of 9 will be 3 divided by negative 1. 3 plus 3 is 6 divided by negative 1. The answer now is negative 6. And it's our final answer for this problem. Okay, time is up, and more example in the next video.